Hello everybody, this is Anthony Lopez here in my apartment on February the 15th of 2017. Today I just wanted to go a little farther with mathematics than I have in the past and go towards the calculus end of things. Now, when looking at all of the different calculus problems that I could try and explain, when I was tutoring kids, one of the things that I noticed most of all that needed to be paid attention to was optimization problems. Now, when I say optimization problems, I'm talking about um, the problems where we're trying to minimize or maximize certain things. For instance, we might want to maximize the amounts of area for a farmer that we can get out of with only a certain amount of fencing. On the other hand, we could be trying to find the minimum amount of fencing to use when we already know we have this much area to use. Now, the reason why I choose talking about optimization problems is solely because not only is there a lot of information, it's usually a word problem, so that already gets most students, but it's also because there's a pretty long process that you have to adhere to. So, today I'm going to tell you my process and my flowchart for how to get through an optimization problem. So let's start my process. The first step in my process is to take all of the given information and boil it down to just two equations with two variables. Now, sometimes this might be a little harder. There might seem like there's three or more variables. However, if there is more than two variables, there's also some sort of constraints, some sort of stipulations that will state variables in, you know, in light of other variables. So maybe it'll say, you know, if we're working in third dimension and there's a length, width, and height, maybe it'll say something like, but length is 2 times height. So every time you see length, you can just plug in 2 times height instead and only be working with height and width as your two variables. Now, after we take all of our information and put it into two variables and two equations, the next step is to use one of those equations and solve for one variable in light of the other. Now, all that means is that we're taking one of those equations and getting one variable by itself. We take all the information that's next to it, we either subtract it, minus it, divide it, multiply by it to get that variable by itself. That is solving for it. And then in light of the other variable just means it's on the other side. It's an equation of that. This could be confusing for some people because they might get stuck on the idea of which equation do I use. Well, in the beginning, with all the given information that we have, one of the things that they give us is that one of the functions is solved. One of the, say we're working with area and perimeter, maybe they say, well, area equals 400. Well, we use that information, we use that equation because we could actually explicitly solve one variable with only the other variable in it. If area is 400 and area is x times y, then it's 400 equals xy. You could solve for y by dividing by x. Thus, y would equal 400 over x. It's explicit. One variable is equal to a function of one variable. You couldn't do that with the perimeter because if you tried, you'd have, perimeter equals x plus y, or 2x plus 2y, I should say. And to get y by itself, you'd have to minus 2x first, so it'd be 2y equals perimeter minus 2x, and then divide by 2. Well, basically you'd have y is a function of perimeter and x, but we don't want it to be a function of two variables. We only want it to be a function of one variable. So thus we have to use the equation that has one variable in light of one variable. once we have solved for one variable in light of the other, the next step is to take that information and plug it into the equation we haven't used yet, which in our case would be perimeter. So once we simplify, we should acknowledge we have one equation, our perimeter equation, with only one variable in it, whether it be x or y. Now the next step is finally our calculus step. We have to derive our equation. So with all of the information we have about derivatives, we're able to derive our equation, perimeter prime. Now the next step is the actual finding of the maximum and minimums. The idea is, for finding a maximum and minimum, we must set the derivative equal to 0. So I split it up. First we find the derivative. Then in this step, we set that derivative equal to 0. This is called a critical point. So we set it equal to 0 and we solve. So we can actually explicitly solve this to where, maybe y equals 15, or if we were working with x, maybe x equals 20. Just making up some numbers here. But we can actually solve. We have an answer. But the most important thing we have to recognize is that we're not done. We still have the most important step left. The sixth step, which is kind of like two steps in one, you're supposed to solve for the other variable and then solve the equation. I call it one step because really all it is finishing the problem algebraically. So we take that explicit actual answer we got for one variable and we plug it in for the other variable. We figure out what that is. We have two variable answers. Well, since the equation in the beginning, the perimeter equation, was two variables, to be able to solve for the perimeter, we needed to have those two actual answers. That's why we were doing all this, to find those two answers to be able to plug in. So since we have them, we plug in and we finally figure out what our perimeter is. Now we are done. Now I know that was a lot of information going at you really fast. The key thing to remember is just the main 6 steps. Maybe you don't need to be taught how to do each step, it's just remembering the process. So you could either look at my diagram I created earlier, or just remember these 6 processes. And I'll remind you right now. The first is that we must find two equations with two variables. Second, we need to take one of those equations and solve for one variable in light of the other. The third step is that we must plug that information into the original equation that we didn't use. And then we need to simplify. Fourth step, we finally use our calculus and we differentiate our equation. Fifth step is we take that derivative and set it equal to 0 and solve so that we have an answer for one of the variables. And then the sixth and final step, which most people forget and you cannot forget, is that we must take that solved variable and use it to solve for the other variable and for the final equation. Thank you for taking your time to listen to my process for solving optimization problems. Hopefully this video was helpful, and I'm looking forward to any comments or questions that you might have. See you next time.